Hi, welcome to Zona Mechanica. There is an MCQ on bending moment. Figure at the margin indicates the weightage of the question, that is 1 mark. A beam is made up of two identical bars AB and BC by hinging them together at B. The end A is built in, that is cantilevered, and the end C is simply supported. The question is, what is the bending moment developed at end A with the load P acting as shown? Well, as you can see in this figure, this is the bar AB and this is the bar BC. Both are hinged together at B. That means the bar BC can rotate about the B, and A is cantilevered, that is fixed end, and C is simply supported. And with this data given, you can see that both the bars AB and BC are of length L, and P is acting at the mid length of BC. Well, so as the two bars are hinged at B and this BC can rotate about B, so the bending moment about B will be 0. That is, summation of bending moment about B will be 0. Okay, so due to this load P, there will develop two reactions at C. Let this is RC, and at A, RA. Okay, so considering the right hand side of this hinge point, so summation of all the moments are 0. That is P into L by 2 minus, since the RC is acting opposite to P, so RC into L will be equal to 0, which implies the RC is equal to P by 2, right? Now the bending moment about A will be due to this load P and this RC, and RA into 0 is 0, so P into L plus L by 2, that is 3L by 2, and minus RC into 2L, that is 3 into PL by 2 minus RC is P by 2 into 2L, so 2 will get cancelled, so 3PL by 2 minus PL, so that is PL by 2, right? So clearly it's matching with option B, PL by 2. So the option B is the correct answer.